In this video, I'll show you how to find the surface area of solids using integrals. The first question reads, set up an equation for the surface area obtained by revolving f at x is equal to sine squared x plus x to the power of 3 around the x-axis from 0 to 15. What they're asking us is to set up an equation. That's it. They're not asking us to integrate for question 1, but they will ask us in question 2. According to this formula right here, what we have to do to set up a surface area equation is have bounds between a and b, which will represent 0 and 15 respectively, for 2 pi times the function, and the function is defined right there, times the square root of 1 plus the derivative of the function to the power of 2 dx. Let's start off by finding out what the derivative of this function is. So we have f at x is equal to sine squared x plus x to the power of 3. The derivative of x to the power of 3 is easy. That's 3x to the power of 2. The derivative of sine squared x, we have to use the product rule for this. And the way we do that is we bring this 2 down. So we have 2 times sine x. And you also find the derivative of sine x, which is cosine x. Just to clean this up a little bit, we have 3x squared plus 2 times sine x cosine x. All I have to do is substitute this into this bigger function, and we end up with our answer. So we have the surface area is equal to 2 pi, and this is for the integral between 0 and 15. Our function, which was sine squared x plus x to the power of 3 times the square root of 1 plus what we found here to the power of 2. 3x squared plus 2 times sine x cosine x to the power of 2 dx. And that's it. That's all you have to do for question 1. For question 2, they ask, find the surface area obtained by revolving y is equal to a third x to the power of 3 around the x-axis from x is equal to 0 to x is equal to 2. A visual representation of this function between these two bounds is shown to your right. Once again, we'll need to find the derivative of this function, but unlike before, we actually have to find the surface area. So to set up our integral, we have surface area is equal to the integral between 0 and 2 pi, the function is 1 over 3 x to the power of 3 times the square root of 1 plus, and let's find the derivative of 1 over 3 x to the power of 3. We'll do that right here. F prime at x is equal to, we'll use the power rule, so we'll bring this 3 and multiply it to the third. That gives us 1 x to the power of 2. So all we do is say 1 plus x to the power of 2, and remember this is being squared. X to the power of 2 to the power of 2 is x to the power of 4 dx. To integrate this, we'll need to use U-Substitution, which is where I substitute this part of the equation with the letter u. I take the derivative, where I end up with this goes to 0, 4x to the power of 3 du, and don't forget dx. Next, we will isolate for dx by dividing both sides by 4x to the power of 3, where we have dx is equal to du over 4 times x to the power of 3. We'll substitute this content into here, where we have the surface area is equal to the integral from 0 to 2 pi over 3 x to the power of 3, the square root of simply u, and dx becomes du over 4x to the power of 3. Notice that this x to the power of 3 and this x to the power of 3 will cancel out, and we can pull out 2 pi over 12 from this integral. Now unfortunately, these lower and upper bounds are in terms of x, but we just made the equation in terms of u. So we have to change 0 and 2. How do we do that? we'll substitute these individually into what we set u equal to. So if I set this x equal to 0, I end up with 1. So at x is equal to 0, we end up with u is equal to 1. And if I set x equal to 2, I end up with u is equal to 17. So I'm going to replace 2 and 0 with 1 and 17. This has suddenly become an easy question. Now I can easily find the integral of u to the power of half. Increase this by 1. I end up with 3 over 2 over 3 over 2, which simplifies to 2u to the power of 3 over 2 over 3. Pi over 6, and I've just reduced this fraction into pi over 6. 2u to the power of 3 over 2 over 3, and now we have to evaluate this at 17 and 1 and subtract what we get for both. So pi over 6, this term evaluated at 17 is 2 times 17 to the power of 3 over 2 divided by 3 is equal to 46.73. 46.73. I did a little bit of rounding. Minus this term at 1 is simply 2 over 3. So your final answer should be, and I'll use my calculator to evaluate this whole thing, pi over 6 times 46.73 minus 2 over 3 gives us the surface area of this function. 24.1 units squared. So there you have it. 2 examples on how to find the surface area of solids using integration.